morning, good evening to everyone here. It's extremely nice to see all the bunch of students, professionals, and friends that we have gathered here today. We're group one, and the project that we've chosen to do is Arty. The web app name is called Arty, and it's basically a visual captioning model for images and artwork. Now, just to start off, how would you describe this picture? Well, it's a painting of mountains and trees, and it almost seems like there's a farm field over there. But at the same time, I asked the same question to a friend of mine, and her response was that this looked a bit doomsday almost because of the shades of brown and black here and there, almost like it's dying. Clearly, there's a subjective interpretation of artwork that exists. Not everyone perceives art the same way. And this is exactly what prompted us to think of our problem statement being, can subjectivity, such as emotions, be maintained while captioning artwork specifically? And the reason why we thought this was important to do is also in terms of the next level intelligence for machine learning would be to really get into the human aspects of emotions and etc. And we were wondering how this could look like for a model trying to perceive something so human such as art. Handing it over to Anna.
So talking a little bit about the technologies and the data set that we used 4 data sets for this project, which is Icon Class, Coco dataset, Flickr, and the Artemis dataset. So we did a basic pre-processing and augmentation to make sure that our model is more robust. We performed basic ADA and we trained the model. We used 3 models, 1 baseline and 2 performance models. And they are written in both Keras and TensorFlow and other things as well. Then we've used Fast API and Docker. And for web app development, we've also used React and Vite for the front end part. Moving over to Sri for the technical architecture.
This is just a quick overview of the technical architecture of our entire app. So not delving too much into the details, we had Docker containers, 4 Docker containers running, 2 for API service, 1 for the front end, and the other one being the app image in itself. When it came to web development, it was mainly through the GitHub as the source control where we developed all our code. When it came to the machine learning side, we used Google Colab notebooks, making use and leveraging the GPUs that were provided there in order to train and test our models. Ultimately, at the end, these were then deployed to the GCP cloud, where the user can then access it in their particular front-end URL.
For the models, we had 2 baseline models. The model architecture was based on the paper called Show, Attend, and Tell. It was attention-based model for image captioning. The first baseline was trained on a dataset Coco, Flickr, and Icon Class. Training size was around 1 lakh image and caption pairs. The vocabulary size was around 10,000. We trained it around for 20 epochs, and the model performed pretty well on photographs, but it was a little underwhelming for the paintings. The second baseline model we did was for the Artemis dataset. It was totally trained on the Artemis dataset, which had around 400,000 image caption pairs. We took a vocabulary size of around 10,000 again, and the training epoch was for, we trained it for around 10 epochs. This was specifically trained to give good subjective descriptions of paintings, so which was something that was not present in the first baseline. Moving over to Nigel, who will explain our SOTM model.
So the final model that we tried was similar to the baseline 2 Artemis model, but in this case, we actually predicted an emotion from the image, and this emotion was fed into the caption generation model. So what this did was actually create a much more rich, much more subjective caption, which you will see in the demo coming ahead. So on the top here, we have the image to emotion classifier, which use the ResNet32 head. And at the bottom, again, we have the ResNet32 connected to a fully connected layer and an LSTM. So LSTM was the model which was used to generate it. The image was fed into both these models and parallelly fed into the decoder part of the model. Moving on to Sri for the demonstration of the app.
So as you can see over here, this is a really beautiful artwork of a bamboo forest, I believe. This is what the model that was trained on Flickr and Coco data set says. A man is sitting on a tree. whereas the baseline trained on the artwork says the tree looks like a beautiful spring day. And the best of all would be the SAT speaker that said the trees are tall and the leaves are blowing in the wind. And the emotion predicted was awe, which I think is very appropriate. As we mentioned before, there's also an option for it to be read out loud. So
The trees are tall and the leaves are blowing in the wind.
so this is, I hope you all could hear that. We've added this mainly also in terms of use case being for those who are perhaps disabled. So we really wanted to also add many other features for the output to be as rich as possible and for people to hear it out also